Okay, you guys, last similar triangle problem like what we've been doing. Okay, so example 16, again, we're going to start off by showing how are the two triangles similar, which I know we already know it's AA. I know that. Okay, but again, the fun part is showing why it's AA, right? I know. Okay, so again, we have two triangles, you guys. We have this upper triangle, so this is going to be very similar to example 15. We have this upper triangle right here. And then we have this big old triangle right here, this one right here. Okay, so we have two overlapping triangles. Okay, so to start off with, since we have overlapping triangles, usually when we have overlapping triangles, that means we have one angle that is in common. So which angle is in common between triangle AIN and triangle ALS? Correct, you guys. Again, like normal, it would be angle A. So angle A is congruent to angle A, and both triangles contain angle A. So I can say angle A is congruent to angle A. And how I know that is because of the reflexive property. Okay, and then the way that we're going to show the other angles are congruent, do you guys spot these sneaky little arrows right here? You probably didn't because they're really sneaky, but we do have these two arrows here. And what do those two arrows mean? It does mean that we have parallel lines. So again, we need to be looking for some of those letters, some of those angle pairs that form when we have parallel lines. Do you guys spot any of those letter shapes that we talked about when we have parallel lines? I see the F's too. Do you guys see it? So we have one F right here. We have like a normal F. And then we kind of have a backwards F right here. So just like our previous problem. And what are the angles called that make the F shape? Sorry guys, I need to drink some water. It would be corresponding angles. And how do corresponding angles relate to each other? They are congruent. So corresponding angles are congruent. So now I can mark some congruent angles in my picture. So I know that angle L is congruent to angle NIA. And I also know that angle S is congruent to angle, let's see here, INA. So there you go. So now I've shown that three angles are congruent, which is pretty cool. Okay, so I can say angle, let's see here, S is congruent to angle ANI. Or I could say angle L is congruent to angle AIN. And how I know that is because they're corresponding angles, and corresponding angles are congruent. So this is the corresponding angle postulate. Okay, so I have shown that three angles are congruent, which is enough information to show that my triangles are similar. How are my two triangles similar? They are similar by the AA similarity, or angle-angle similarity. Nice. Sorry guys, I meant to box around, but you know, it's okay. Okay, so now that we know triangles are similar, guess what that means? It means that our sides are proportionate. So I can set up proportions to solve for x and y. Okay, so I'm going to go ahead and set up for my x and my y. I'm going to start with the small triangle first, up top, and then the big triangle. So my small triangle, for x, my small triangle contains x. So an x is the whole side. So it's going to be x over, now x is in between the 1 arc and the 3 arc. Okay, if we look at the big triangle, which side is in between the 1 arc and the 3 arc? Now, be careful, it would be the entire side. So side AS. Okay, so side AS is made up of AN and NS. So what do I do with each of these parts to get the whole side length? I would have to add them together. So to get this whole thing, which I don't have much space, to get this whole thing, I need to add those two together. So I need to add the x and the 6 together. So this side corresponds to this whole side, which is x plus 6. So be careful. Okay, and now I'm going to set up for y. So y is in between my 3 arc and my 2 arc, and it's in the small triangle, which I'm putting the smaller triangle sides in the numerator. So I have y over which side of my big triangle has the 3 arcs and the 2 arcs. Holy hot dog, it would be the 9. Okay, and now we need to find our scale factor, which I have room now. I planned ahead. Okay, so my scale factor, I'm going to write down here. This is what I'm going to use 2 times in each of my proportions since I'm already given these values. So the 2 sides that I already have numbers for are these sides in my triangle. So in the little triangle, it's a 5. Now, what is the length of this entire side in my big triangle? So that's a 5, sorry. Okay, I know this whole side is made up of AI and IL. So what do I do with the 5 and the 10 to get this whole side length? I would add them together. You guys are geniuses. Okay, so 5 plus 10 is 15. Okay, so down here it's going to be 5 over 15, and that will reduce down. I can divide both of these by 5. Okay, so 5 divided by 5 is 1, and 15 divided by 5 is 3. Guys, so the scale factor that I'm going to use in each of my proportions is 1/3. So I'm going to use 1/3 here, and 1/3 here. Okay, and then from here, we're just going to cross multiply because we have 2 proportions. All right, we got this, you guys. You guys are cross multiplying pros, so let's do this. Okay, so I'm going to multiply x plus 6 times 1. Now, when you multiply anything to 1, you get the same answer. So when I multiply x plus 6 to 1, I'm going to get x plus 6. Now, you could write it like 1 times x plus 6, and you could distribute the 1, but 1 times x is x, and 1 times 6 is 6. So you ultimately end up with x plus 6. So I'll leave it up to you if you want to write it like this, or you can just go ahead and write x plus 6. Okay, and now let's go the other way. So 3 times x gives me a 3x. All right, let's do this thing. Let's solve for x. So first of all, I need to join together my 2 x's because they're best friends and they're apart right now. They need to be together. Okay, so I'm going to bring my x to the other side, which there's secretly a 1 in front of my x. So the way I bring a positive x to the other side is by subtracting it on both sides, which 1x minus 1x cancels and turns to 0. 3x minus 1x is 2x. So I have 6 equals 2x. And then how I solve for x, the 2 and the x are secretly multiplying. So how I bring the 2 over to the other side is by dividing both sides by 2, which 2 divided by 2 cancels and turns to 1, and 6 divided by 2 is 3. So guess what, you guys? X is 3. Pretty incredible in my opinion. Okay, and don't forget about the scale factor down here. I'm just hiding it so you can see my work a little bit better, but make sure you look at that. But anyways, in my next proportion, again, all we gotta do is cross multiply. So let's do it. Okay, so 3 times y is gonna give me 3y, and that will equal 1 times 9. Which 1 times 9 is 9. And now we just gotta solve for x. Okay, which the 3 and the y are secretly multiplying. So the way I bring 3 to the other side is by dividing both sides by 3. 3 divided by 3 cancels and turns to 1. 9 divided by 3 is 3. So guess what, you guys? Y is also 3. That was kind of cool. That worked out nicely. And let me just double check everything. Make sure I did it all right. Yeah, looks good. All right, well, guess what? That's it, you guys. Way to go. Nice job.